everyone, this is Nagaraju Rebba. In my last class, I discussed so what is the definition of the matter and what is the importance of the important classification of the matter and what are the examples of the matter. I discussed all those things, and at the same time in my last class I discussed with you what are the important physical and chemical properties of the solid materials and what are the examples of the solid materials and what are the important characteristic properties of the solid materials I discussed. And in this class I am going to discuss liquid materials and as well as gaseous materials. So now you can see, now in this class I am going to discuss the liquid materials. So liquid materials. So first I am writing the first point based on the liquid materials. You know that liquid materials liquids have fixed mass and volume. And the second point, liquids does not have fixed shape. And the third point, liquids contains intermolecular distance. Intermolecular distance are not short. And next, liquids contains lesser intermolecular force. And the next point, liquids contains lesser intermolecular force. Liquids contains lesser attractive force. And see here, in this class I am going to discuss so what are the characteristic properties of the liquids and what are the properties of the liquids also I am discussing in this class. The first one you will see here, so liquids does not have a fixed shape. So the liquids does not have a fixed shape. That's very, very important. The liquid materials does not have a fixed shape. And the second point, the liquids have a fixed mass. So the liquid materials have the fixed mass and fixed volume. The liquid materials contains the fixed mass and fixed volume, but the liquid materials does not contain a fixed shape. So it doesn't have the fixed shape. And the third point, what is the third point means here? The liquids contains intermolecular distance are not strong. So the liquids are contains the intermolecular force of intermolecular distance. Intermolecular distance are not short. Means in the liquid molecules, the intermolecular distance is a very, it will contain some distance. So when compared with these solid materials, the liquid materials are contains the very short, means just like in the liquid materials they are all contains the short, very lesser distance. But in the case of a liquid materials, the distance will be present on the liquid molecules. And the next point, the liquids contains lesser intermolecular force. The liquid molecules are contains the lesser intermolecular force. Why? Because the distance is more. The distance is more means lesser intermolecular forces. And at the same time, I am saying one more point. The liquids contains the lesser attractive force. The liquid molecules are contains the lesser attractive force. So intermolecular distance is the less, and yes, just like force of attraction is also less, and therefore attractive force is also very less when comparing with the solid materials. Why? Because here when comparing with the solid materials, these liquid materials are contains the some distance at a particular distance. So that's why these materials are contains the lesser attractive force, and at the same time the intermolecular distance is very short. Intermolecular distance is not very short. Intermolecular distance is not very short, and at the same time attractive force is also very less in the liquid molecules. Attractive force is also very less in the liquid molecules. These are all the important properties of the liquids. Once again I am saying liquids have a fixed mass and a fixed volume. The liquid molecules have the fixed mass and the fixed volume, and the liquids does not have a fixed shape. These liquid molecules does not contain any fixed shape, but the liquid molecules contain the fixed mass and fixed volume also, and at the same time liquids contains intermolecular distance. Intermolecular distance are not short. Intermolecular distance are not short, and liquids contains a lesser intermolecular force. The liquid molecules are contains the lesser attractive force, and at the same time liquids contains a lesser attractive force. Liquids are contains the lesser attractive force when comparing with the solid materials. When comparing with the solid materials, and then here you will see based on next point from this next point. What is the next point of in this liquid molecules means here the liquid molecules are not rigid in structure. Liquid molecules are not rigid in structure. Not rigid. Not rigid in structure. So means it doesn't have a particular liquid molecules does not contain a residue structure. Suppose if you take some amount of a water molecule, you can spill some of the water molecule on the floor. So what will happen? So how we will say the shape of the water molecule means we can't say that. If you pour the water molecule on the floor, what will happen means the water molecules are moves on one place to another place. If you pour on the water molecule on the floor, so what will happen means by the pouring of the water molecules are moved from one place to another place. That's why we are saying that the liquid molecules are not rigid in structure. The liquid molecules are not rigid in structure. So based on these all properties, now I am going to explain one important activity based on the liquids. So see here activity 1. So what is the activity 1 here means? So suppose here I am saying that I am taking the different vessels. So see here I am taking the different containers. See here, in the board I recognize the different types of containers, means different types of tumblers. So by the observation of these different types of tumblers, what I am saying that here, suppose I am taking here the 50 ml of a water molecule. So first I am taking the 50 ml of a water molecule. See here, by the observation of these 50 ml of a water molecule, here you will see. So in this tumbler I take as a 50 ml of a water molecule. Like these are 50 ml of a water molecule is present only here. So this is called as a 50 ml of a water molecule. By the pouring of the first tumbler, this one is called as a 50 ml of a water molecule. And at the same time, in this vessel also, I am taking the same amount of the water molecule. Like this vessel also, this container also I taken as a same amount of the water molecule. And this one is also called as a 50 ml of a water molecule. And in this vessel also I taken as the same amount of a water molecule. Like this is called as a 50 ml of a water molecule, and in this vessel also I taken as the same amount of a water molecule. And like here also 50 ml means simply we will get like this is called as a, and like this tumbler also. See here, by the observation of these all vessels, what I am saying that, so this one is called as a 50 ml of a water molecule. I taken 50 ml of a water molecule in the different vessels or different containers. In this container, this is called as the volume of the 50 ml of a water molecule. So this one is called as the volume of the 50 ml of a water molecule. 50 ml of water molecule in this container. So therefore, so this one is called as a here. So the 50 ml means it is called as a volume. 50 ml means it is called as a mass. Mass of a water molecule is called as a 50 ml. And at the same time here, this one is called as a volume. So the volume of this vessel is called as a like this is called as a volume of this vessel. And at the same time, so the shape of this one. So shape here the different containers. These are all the different containers. These the different containers are contains the different shapes. These the different containers are contains the different shapes. So that's why here the shape of the liquid molecules are not fixed. The shape of the liquid molecules are does not fixed. And by the observation of the mass and volume. Here 50 ml, that is called as the volume of the liquid molecule. 50 ml means it is nothing but a volume of the liquid molecule. So by the pouring of that 50 ml of a water molecule, by the pouring of 50 ml of a water molecule in the different containers, it will contain the different shape. So by the pouring of that liquid molecule, it's mainly depends on the shape of the container. If the shape of the container is very, very large, in that case, so the volume of the water molecule will be decreased. Suppose you will see this is called as one of the container. So here to here, this one is called as the volume of these are 50 ml of a water molecule. So mainly these liquid particles shape is mainly depends on this container, and at the same time the volume of the liquid molecule is mainly depends on this container, and at the same time mass of the liquid molecule also depends on that container only. And at the same time by the observation of these container, here also what I am saying that this one is called as a 50 ml of a water molecule, but the shape of the container is different. Why? Because we are taking the different container, so that's why the shape of the container is different. That's why here the volume is also different. Here when comparing with these volume and these volume, both are the different. The volumes are the different because of the liquid molecules shape and the liquid molecules volume and mass. It's mainly depends on the which type of a container. Which type of a container we are taking, it's mainly depends on that container. And by the observation of like this is called as one of the tumbler. So means a container. In this container also we taken as a 50 ml of a water molecule only. 50 ml of a water molecule. But here the shape of the molecules are completely changed. The shape of the molecules are completely different, and the volume of the tumbler also different. So that's why, and at the same time by the observation of this one, here to here, this is called as a volume of these as a container, volume of this container, but the amount of this one is called as a 50 ml of a water molecule. 50 ml of a water molecule, and at the same time this one also called as a one of the different container. Here also we taken as a 50 ml of a water molecule. 50 ml of a water molecule. By the shape of the container is completely different. Why? Because we are taking which type of a container. So the shape of the molecule is mainly depends on that container. and the volume of the liquid is also mainly depends on that container. So therefore, when we are saying that what is the volume of the liquid molecules, what is the shape of the liquid molecules means what is the shape of this one means that is called as the shape of the liquid molecule. And what is the shape of the container? That is called as the shape of the liquid. That's why the liquids does not contain any fixed shape. The liquid molecules does not contain any fixed shape. So which type of a container we are taking? That is called as the shape of that particular liquid molecule. So by the observation of these all containers, so here we take it as a 50 ml of a water molecule. In this example, we take it as in this activity, we take it as a 50 ml of a water molecule. In that 50 ml of a water molecule, these are all the different containers. By the pouring of that 50 ml of a water molecule in the different containers, that the different containers are contains the different volume and a different shape. So therefore, before I explained some properties of the liquids. So therefore, this one is nothing but a activity based on the different containers by the pouring of the water molecule. By the pouring of the only 50 ml of a water molecule means the volume of the water molecule is fixed. The shape of the molecule is different, but the volume is completely fixed. That is called as a 50 ml. So the volume is fixed, but the shapes of the molecules are different based on that containers. Based on that containers. In the place of a water molecule, simply you will take 0.5 liters of oil. 0.5 liters of oil. So in that particular case, these all containers are contain the same volume means no, because of when compared with the water molecule and oil molecules, both are the different. So when compared with the water molecule, the oil molecules are contain the some more attractive force when compared with the water molecule only. So therefore, the intermolecular distance in the oil particles are very very close when compared with the water molecule. So that's why when we will take the 50 ml, same 50 ml of oil. Same 50 ml of oil. So in that particular case, the shape of the molecule is the same means it's not a same. It's not a same. And by the taking of the milk particles, in the same example, we will take the milk particles. In that particular case also, these all the what is that containers are contain the same shape means no. So when compared with the water molecule, so the liquid molecules also contain the some attractive force. So that's why when compared with the water molecule, the liquid milk particles and as well as the oil particles are contain the attractive force. That's why they are all contain the some little bit difference. They are all contain the some little bit difference in their shape and volume also. So they are all contain the little bit difference of the shape. So therefore, this is called as a most important activity based on the liquid molecules. Most important activity based on the liquid molecules. And then I am going to discuss the gaseous molecules. Now I am going to discuss the gaseous molecules. See here the gaseous molecules. So gaseous molecules, first point I am writing there. See here, I am explaining the properties of the gaseous molecules. So gases does not have fixed shape. Gases does not have fixed shape. And the second point is that gases does not have a fixed mass and volume. The gases does not have a fixed mass and volume. So simply we are saying gases are neither have a fixed shape nor a fixed volume. And at the same time, gases contains a intermolecular distance or longer. The gas molecules are contains the intermolecular distance or longer. And at the same time, the gases contains an intermolecular attraction or very less. Intermolecular attraction or very less. Suppose you will see, I am saying some general examples based on these gaseous molecules. You know that in this classroom, I am talking to you, so immediately you are getting my voice. So when I am talking to you, when I am explaining to you, so immediately you are getting my voice. Because of, so in our atmosphere contains so many gas molecules. In our atmosphere contains so many gas molecules like nitrogen gas, oxygen gas, next chlorine gas, bromine gas, hydrogen gas, helium gas, carbon dioxide gas, carbon monoxide gas, sulfur dioxide gas and sulfur trioxide gas. Like different gas molecules are present in our surroundings. So based on that gas molecules, here the gas molecules are acting as one of the medium. The gas molecules are acting as one of the medium in between you and me. That's why what I am talking to you, immediately you are getting my voice. So what I am talking to you, immediately you are getting my voice because of in between you and me. So some gas molecules are acting as a medium. Some gas molecules are acting as a medium. Suppose you will see this is called as a classroom. In this classroom, how we will calculate the volume of the gas molecule means we can't calculate because of so many gas molecules are moving in our surroundings. So many gas molecules we are moving in our surroundings. That's why how much volume is there in the classroom, that is called as the volume of the gas molecules. So simply we are saying. And at the same time here you will see what I am saying, that gases contains intermolecular attraction are very less. So means gas molecules does not contain any attractive force. The gas molecules does not contain any attractive force. Why? Because the volume of the gas molecules does not fix and the mass of the gas molecules is okay. But what is the shape of the gas molecules means we can't calculate. Means we can't say that what is the shape of the gas molecules means we can't say because of it is nothing but one of the imaginary part. It is nothing but one of the imaginary part. Try to understand. I will say one example based on these. And at the same time, gas molecules does not contain a rigid structure also. The gas molecules does not contain the rigid structure. Why? Because I am saying the example. See here. So here the gas molecules does not contain the rigid structure also. Suppose you will see this is called as a container. So what is the volume of the container means like this is called as the volume of the container. So like here what I am saying that N2 gas plus O2 gas is there, nitrogen gas and oxygen gas. You know that in our atmosphere, so 75 means 75% of the in our atmosphere is occupied by the nitrogen gas. 75%. So the 75% of the in our atmosphere is occupied by the nitrogen gas, and almost 22% is occupied by the oxygen gas. So 22% of the in our atmosphere is occupied by the oxygen gas, and at the same time remaining all gas molecules. So carbon dioxide, carbon monoxide, next sulfur dioxide, sulfur trioxide, helium, hydrogen, next argon, like that. These are all gas molecules are contains a very lesser amount. Very lesser amount, that is approximately 0.5 or 0.9. So approximately 0.5 or 0.9. But most of the in our atmosphere, most of in our surroundings are occupied by the nitrogen gas. And the second, which gas is occupied means oxygen gas is occupied remaining percentage. So by the observation of here, what I am saying that here in this container, I take it as a just like nitrogen gas and oxygen gas. In this container, I take it as a nitrogen gas and oxygen gas. So what is the volume of these two gas molecules in the container means we can't say that because of so what is the volume of the container? So we are saying that volume of the gas molecules also same. So how much what is the volume of the container? The volume of the container only volume of the gas molecules. The volume of the container only volume of the gas molecules. That's why individually we can't say that the volume of the nitrogen gas and oxygen gas in this container. Why? Because so these gas molecules are collision with the walls of the container, and at the same time sometimes these gas molecules are collision with each other. Collision means it is nothing but a fighting. Collision means it is nothing but a fighting. The fighting of the two gas molecules. The fighting of the two gas molecules are, so sometimes the gas molecules are fighting with walls of the container. So like that, so these gas molecules are fighting with walls of the container, and at the same time, so these gas molecules are sometimes collision with each other. You know that sometimes I am talking to you, so in that particular case, sometimes you are getting the more voice. So means it is nothing but a resound. A resound means in that particular case, my voice, like that, my voice is bombarding with the walls of the classroom. And at the same time my voice is bombarding with the entire classroom. That's why you are getting the resound. You are getting the resound. At the same time here also, what I am saying that these gas molecules are collision with each other. Collision means it is nothing but a fighting. So the two gas molecules are collision with each other, and at the same time the gas molecules are collision with the walls of the containers. Walls of the containers, and at the same time here the gas molecules are acting as a elastic in nature. The gas molecules are acting as a elastic in nature. Why? Because sometimes the both gas molecules are collision with each other. Immediately by the collision means by the fighting means immediately the gas molecules will lose the amount of energy. By the collision means that gas molecules will lose the amount of energy, but here these gas molecules are acting as a elastic in nature. And at the same time, what I am saying that sometimes these gas molecules are collision with the walls of the containers. Sometimes these gas molecules are collision with the walls of the containers. In that particular case also, the gas molecules are lose of some amount of energy. So therefore, and again the gas molecules are move entirely a container. So therefore, we can't say that. So what is the volume of the beaker? That is called as the volume of the gas molecules. What is the volume of the container? That is called as the volume of the gas molecules. And at the same time, by the observation of the classroom also. So what is the volume of the classroom? That is called as the volume of that particular gas molecules. So that's why, so simply we are saying that volume of the gas molecule, which container we are taking, that is called as the volume. That volume is called as the volume of the gas molecules. That volume is called as the volume of the gas molecules. This is called as a very, very important point. So this is nothing but a very, very important point. And then you can observe that in this gas molecules, what I am saying that you know that in our general life, so we are seeing that nowadays in our Hyderabad also, so most of in our Hyderabad, like that in our Pathabasti, like that Secunderabad railway station, and you can observe some areas. In that areas they are using the CNG, like that CNG autos. CNG autos. So the CNG means it is nothing but a compressed natural gas. Compressed natural gas. So compressed natural gas, but in our house we are using, this is called as a LPG. LPG means it is called as a liquefied petroleum gas. Liquefied petroleum gas. Liquefied petroleum gas. See here. So CNG means it is nothing but a compressed natural gas. CNG means it is nothing but a compressed natural gas, and LPG means it is called as a liquefied petroleum gas. Liquefied petroleum gas. You know that in our Hyderabad nowadays, so most of the autos they are using that CNG gas. CNG gas, and at the same time in our house we are using, this is called as a LPG, liquefied petroleum gas. So actually the weight of the liquefied, that cylinder is more. The weight of the cylinder is more, but how much amount of the gas is stored on the cylinder means almost it is called as 14.5 kgs. 14.5 kgs of the gas is stored on the what is that cylinder? 14.5 kgs of the gas only stored on the cylinder, but the weight of the cylinder is more weight. So why they are keeping that gas molecules stored on the cylinder means because of it is nothing but some safety precautions. And at the same time you see, so in our general life we are using that CNG gas. CNG gas. How they are storing on the CNG gas means simply in the backside of that autos, or nowadays cars also we are using that CNG gas. So when comparing with the petrol and CNG, which one give the more mileage means CNG give the more mileage. The CNG gas will give the more mileage. That's why most of the vehicles nowadays they are migrating to the petrol to CNG gas. So in the car also, by the observation of the car, in the back dicky they are keeping one just like a tank. In that tank they are storing, that is called as a gas. So by the this is called as a CNG gas and LPG, liquefied petroleum gas. In that liquefied petroleum gas also, the gas molecule is converting into a liquid. By the shaking of the cylinder, so what we will feel like some liquid molecules are there on the cylinder. But actually it is not a liquid, it is a gas. That gas is a compressed. That gas is a compressed on the cylinder. So when you open that lid, what will happen? Like that sound will comes outside. So means it is nothing but comes out. The gas molecules are comes out from the high pressure area to low pressure area. High pressure zone to low pressure zone. So inside the cylinder that is called as a high pressure area, outside the cylinder that is called as a low pressure area. By the observation of the scent bottle also. By the observation of the scent bottle also. So just like if you see the deodorant, so simply you can press it immediately, that gas molecules are comes outside. That gas molecules are comes outside. So therefore this is called as just like a gaseous molecules. And at the same time I am saying the very important example. So suppose you will keep here unlit incense stick. Unlit incense stick, and you can go to that corner of the room and you will see the smell of the incense stick. So because of it is nothing but unlit, it doesn't produce the any smell. So if you light it, so by the burning of the incense stick here, and you will see, you will go and stand the another corner of the room, and you will see immediately. So the smell is spreading on the one place to another place. The smell is spreading on the one place to another place because of here the incense stick, lighting incense stick and another corner of the room. So some gas molecules are moves on one place to another place. The gas molecules are moves on one place to another place, and you know that sometimes we are using this spray also. By the using of this spray in the one corner of the room, and immediately that smell is spreads on the another corners of the rooms also. Another corner of the room also. So therefore it is nothing but a spreading of a gas molecule. The spreading of a gas molecule from one place to another place. From one place to another place, here the air particles are acting as one of the medium. The air particles are acting as one of the medium. So this is also very important in the gaseous materials. And next I am going to discuss some very important activity based on these gaseous molecules. That is called as a compressibility. So compressibility here. So by the observation of a compressibility here, I am saying your example. See here. So by the observation of these compressibility. So what is the compressibility means? Just like by the increasing of the air particles. Suppose you will see here I am saying that. So this is called as one of the beaker. This is called as one of the beaker. So in this beaker I take it as a nitrogen gas and oxygen gas. Nitrogen gas and oxygen gas. So initially the volume of the gas molecules like so what is the volume of the container? That is called as the volume of the gas molecules. Initially, what is the volume of the gas molecules means what is the volume of the container? That is called as the volume of the gas molecules. After we are applying the pressure, by the applying of the pressure, so what will happen is simply you will see here, I am applying the pressure. So simply, so this is nothing but a compressor. Means I am applying the pressure. By the applying of the pressure, what will happen means the volume will be decreased. By the applying of the pressure, what will happen means the volume will be reduced. By the applying of the pressure, what will happen means the volume will be reduced. Now you can see this is called as the volume of the gas molecules. But initially this one is called as the volume of the gas molecules. After we are applying the pressure, what will happen means the volume will be reduced. The volume will be reduced. See, I will say the simple example. This one is called as a syringe. This one is called as a syringe. So by the observation of this syringe, and this is called as a nozzle, syringe nozzle. In this syringe, you will take some amount of the air particles. Means if you keep in your finger here in the nozzle of the what is that syringe, and you can press it. What will happen means just like that air particles does not move. That air particles, why? Because here we kept a finger, and at the same time we are using the just like we are pressing the piston. What will happen here means just like some air particles are present on the syringe. some air particles are present on the syringe, and at the same time we closed in this nozzle. We closed down that nozzle, so that's why there is no movement of the gas molecules. There is no passing of the gas molecules. There is no escaping of the gas molecules. Why? Because here we kept just like in our finger. By the keeping of the finger, what will happen means there is no movement of, there is no escaping of a gas molecules. That's why here we will observe that this one is nothing but a compress. By the compressing of the piston. By the compressing of the piston, what will happen means it doesn't move. It doesn't move. Why? Because here the gas molecules are very tired. At the same time, what I am saying that here, by the applying of the pressure, the volume will be reduced. By the applying of the pressure, what will happen? Just like the volume will be reduced. And here also, just like we kept the finger. That's why the volume is fixed. So we can't piston it. Why? Because here the gas molecules are very close. So that's why here this is nothing but just like calculation of compressibility. And if in case in the place of air particles, if you take the some amount of the water molecule, in that particular case also there is no movement of the gas molecules. When comparing with the gas molecules, it will contain the some movement. Yeah, in the gas molecules it will contain some movement, but in the contents of liquid molecules it doesn't contain, and in the case of a solid molecules does not contain any compressibility. The solid molecules does not contain any compressibility, but liquid molecules are contain the little bit compressibility. The liquid molecules are contain the little bit compressibility, but the gaseous molecules are contain the compressibility. Like that here you will see. So initially what I told that this is total one is nothing but the volume of the beaker. In this beaker we taken as two gas molecules, nitrogen gas and oxygen gas. Initially what I said that, so the total volume is called as the volume of the gas molecules. If you apply the pressure, by the applying of the pressure, what will happen means the volume will be reduced. The volume will be reduced means the attractive forces will be increased. Initially, the gas molecules are contain the lesser attractive forces. But after we are applying the pressure, by the applying of the pressure means volume will be reduced. By the volume will be reduced means gaseous molecules are very close to each other. By the gaseous molecules are very close to each other means the gaseous molecules are contain the attractive forces. The gaseous molecules are contain the attractive forces. Therefore, that one is called as a compressibility. But in our textbook they given the activity 2. Based on the activity 2, what I am saying that if you take the one syringe, by the observation of that syringe, so it will contain the one nozzle, and at the same time it will contain the one piston. So by the closing of the nozzle, you can piston it. What will happen is the gaseous molecules, so it will slowly, just like if you keep here the finger, so means the closing of the nozzle, what will happen is so this the piston does not move. So at the same time, if you take the water molecule and the oil molecule, so what will happen is it will contain the little bit compressibility, but gaseous molecules are contain the more compressibility. The gaseous molecules are contains the more compressibility. So therefore, this is called as a characteristics of the gaseous molecules and liquid molecules. Gaseous molecules and liquid molecules. So thank you very much. In my next class, I will discuss with you some important basic points which are present on the matter around us. Thank you very much.